Lesson 4 is on the properties of similar polygons. So we're going to take Lesson 4 and we're going to talk more specifically about similar figures and similar polygons instead of talking about them necessarily as transformations like translations and reflections and dilations. Okay? So let's start with your real-world application here. Okay? They give you the first problem right here. It says Elsa is printing pictures at a photo kiosk in the store. She can choose between 4x6 prints or 5x7 prints. Are the side lengths of the two prints proportional? Well, they're not proportional because if you take the corresponding sides, like 4 and 5 go together, 4 and 5 make 4/5. 6 and 7 make 6/7. They're not the same fractions. They don't reduce to be equivalent. So therefore, the two prints are not proportional. All right? Let's look at the first problem down here. Use a centimeter ruler, measure the sides of the two triangles. Then use a protractor to measure the angles and write the results in the table. Okay? Now, you don't have to go through and do those because I know most of you probably don't have a protractor or even a ruler at home. So I'll go ahead and show you what they are here. Okay? Triangle EDF. Okay, here are the side lengths. DE, EF, and FD. And here are the angle measures, 33, 100, and 47. Now, if we take the bigger triangle, triangle LJK, we can see that the angles are congruent. Do you see how the angle measures are the same? But just because the angle measures are the same does not necessarily mean that they are similar. Their side lengths have to be proportional. So what we need to do is we need to check out the side lengths. So if we go DE, that corresponds with JL. Okay, so we have 2.7 over 4.1. We're going to make that a fraction and reduce it. We need to check EF, and we need to check JK. So EF is 2, JK is 3. Well, that makes a fraction of 2/3. Let's check the last one. FD corresponds with KL. Well, if you take 3.6 over 5.4, it reduces to 2/3. So each one of these sides, their corresponding sides, reduces to 2/3. Okay? Therefore, these two triangles are similar because they have the congruent angle measures, and their side lengths, each one of them are proportional, and the proportion or the scale factor is 2/3. Okay, let's look at your key concept here. This is similar polygons. If two polygons are similar, then their corresponding angles are congruent, and the measures of their corresponding sides are proportional. So they have to have the same angle measures, and their sides have to be proportional. Okay. Here, if you didn't notice, right there, that's the sign for similar. It's just the squiggly line. We lose the equal sign, and it just becomes the squiggly. So we would say triangle ABC is similar to triangle XYZ. Okay? And the same thing, we use the word corresponding. A corresponds with X, C corresponds with Z, and the same thing with side lengths. YZ corresponds with BC. And that's how we set up our proportions to find the similar sides. Let's look at an example here. Example 1. Determine whether rectangle HJKL is similar to rectangle MNPQ, and then explain. Alright, so let's take a look at our angles first, because we know they have to be the same. So we have all four are 90, all four are 90 here. So we're okay, we can move on to the next step, which is to check the sides. Okay? So let's see what corresponds here. If we look at our statement, our similar statement up here, we know that HJ corresponds with MN. So HJ, which is right here, corresponds with NM. Well, that gives us a fraction of 7/10. Okay? Let's check another side. Let's do JK, and that corresponds with NP. Now that gives us a fraction of 3/6, which reduces to 1/2. So right off the bat, we kind of have a problem here. We have two fractions that are different. And like we learned in our last lesson, if they're different, they're not equivalent. Okay? Therefore, they're not similar. So these two shapes are not similar because we didn't use the same proportion or the same scale factor to get the lengths of the sides. Okay? So what I would like for you to do right now, try the got it problem. Okay? Use corresponding sides and see if we can get the same fractions. Okay. I'm going to start with AB and XY. Okay, AB is 8, XY is 12. 8 over 12 reduces to 2/3. Okay. Now let's try another side. AC and XY match up. So 6 over 8, that reduces to 3/4. So right off the bat, we know we have two fractions that are not the same. So we say they are not similar because their side lengths are not proportional. This is not a dilation. Okay, they're not similar figures because their proportions are different. All right. Let's look at example 2. Example 2 talks about finding missing measures. Okay, so now we're kind of getting more into the algebra piece again, where they're going to give us side lengths and we have to find a missing piece somewhere. Okay? Quadrilateral WXYZ is similar to quadrilateral ABCD. And again, you can use this right here to find corresponding sides. Okay. Letter A says, describe the transformations that map WXYZ onto ABCD. So they want to know, what do we have to do to get this shape over here onto this one? Well, we know they're not the same size, so we're going to have to do a dilation. Okay. So let's check dilations here. There's two ways you can do it. Okay. We need to find missing sides. There are two methods to finding missing sides, and I personally like one method better than the other. You can choose which method you want to do, okay? And I will show you how to do it both ways, but in class I'll likely probably do it one way over the other. The first way they're going to do it, they call method 1, and this is using a scale factor, okay? So what they've done, they've taken two sides that correspond. So they chose YZ and CD. So if you look up here, here's YZ and here's CD. Those two sides correspond. So what they've done is they made it a fraction and reduced it. Okay? They're going to use this right here, this 3 over 2, as a scale factor. So to find the missing side, which is M right here, do you see where we're trying to find this length right here, M? They're going to use the side that corresponds with M, which is 12. Okay? 12 and M correspond. However, we don't know what M is. So what they're going to do is they're going to take this 3/2 and they're going to multiply it by the scale factor. Or 3/2 is your scale factor. They're going to multiply it by 12. So 3/2 of 12 is 18. So what they're saying is this side right here is 18. And we got that by using the scale factor of 3. So that's method 1. Method 2, which I prefer, is actually you set up proportions and you cross multiply and divide. I think this is probably the one that you're most familiar with. Okay, they still used YZ and CD, okay, 15/10, but instead of multiplying that by 12, we set up another ratio, M over 12, the missing. So then we cross multiply. M times 10 is 10M. Then we go 12 times 15. 12 times 15 is 180. Then we just solve the equation and we get 18. So in either case, we end up with the same answer. It just is if you like to use the scale factor and do some multiplication, or you like to set up a proportion, cross multiply and divide. Again, I tend to like method 2 a little bit better, just because we're more familiar with it. But in your next got it problems here, I'll do B and C both ways so you can see both types of problems. So right now, go ahead and pause the video and try these got it problems. You're looking for the missing side, okay? All right, let's look at WZ. We're trying to find WZ, which is this length right here. Now this length corresponds with this length right here. So we're gonna have to use this 13. So let's see. I forget which way I did this one. Okay, I set this one up as a proportion, cross multiplying and dividing. Okay, so here's my first one. Oops. I went M for the missing side, I just put a variable right there, m over 13, because they correspond, equals, I picked two other sides that correspond. I used 15 and 10. Okay. Now notice, because I have m on top here, which is on this side, I had to use 15 on top as well. Okay, so corresponding parts of they have to be on the same level here. So what I did was I cross multiplied and divided. Okay. Let me just get rid of that. So m times 10 is 10m. 13 times 5 is 195. Then I divide both sides by 10, and I get 19.5. So this missing piece right here is 19.5. Okay. Now you could have done a scale factor. You could have taken 15 tenths and reduced it to 3 halves, and then just took 13 times 3 halves, and you would have gotten 19.5. Okay. Now this one, for AB, we're trying to find this missing piece right here. I did it using a scale factor. Okay. I took 10 fifteenths, and I reduced it to 2/3. Okay, so 10 fifteenths, reduce it to 2/3. Here's my scale factor. So what I'm going to do is I'm going to take that corresponding side to AB, which is 24, and I'm going to take 24 and multiply it by 2/3, and I get 16. Okay, so this missing side right here, AB, is 16. Now I could have set it up like this and still gotten the same answer, and that works. Okay, I don't care which way you do it. Whatever you understand the best is how you can do it. Okay, as long as you show your work. So I think this is the end of the lesson, so go ahead, try your guided practice problems, and we'll spend more time tomorrow going over lesson 3 and lesson 4 since they're pretty similar. Okay? Alright, I'll see you guys tomorrow in class.